today's topic, which I am taking, is a sign test. Now, in this particular one, the important is that this test, sign test, is used to test the consistency. You have to test whether there is a consistency or consistent, whether there is a consistent difference between pair of observations. What the meaning of pair of observation means? Pre-test and post-test. So if it is my pre-test data, then post-test data will be of mine. And that is why it's a pair. So I become my own pair. Pair of observations. So there must be consistent difference between the pair of observations. So this is what is more important. And then is pair of observation, and it determines if one member of the pair tends to be greater than the other member of the pair. So that means you have the pair, and it says if one of the member of the pair of one differs from the other. That is what the sign test will try to find out. Then sign test can also test if the median of a collection of number of collection of numbers is significantly greater if a less than a specified value. You can specify the value, and then the third is that the sample must be randomly selected from the population, from each population. Say you may take the population, and when you are taking the two people, then you are selecting them randomly. That's what exactly is the meaning of that. The sample must be dependent or paired. You may take a pair also, or you may take the dependent also. Then important is that that independent samples cannot be meaningfully paired. If you have independent samples, then you cannot pair them. Then the samples may not come from the normally distributed population. And then another is when you say that they are not normally distributed, then my dear friend, you know that in the normal distribution, there is a left tail and there is a right tail. So therefore, the meaning is that your sample may belong to the left tail or the right tail or left and right. It does not matter. So that is the meaning. So may not come from the normally distributed population. So that means the members may belong to the left-tailed or right-tailed or the two-tailed. Two-tailed means on left as well as right. Either it is completely left or it is completely right, or it may be in between. Because two-tail is always in between. The third is the sample must be randomly selected from each population. Whatever the population that you have, and when you are selecting the member, what is the meaning of random? Random means each member will have equal chance to be selected. That's the meaning of the random. So therefore, if it is a homogeneous group, then this condition is satisfied. If your group is a heterogeneous, then this condition is not satisfied. So that is what you should understand. So once they say randomly, randomly means each member will have say you may have male and female. So you have the male people and the female people. So you should select the randomly so that it can be male as well as it can be female. So it is, once I say each population means it is a male population as well as a female population. That means your population is a heterogeneous one. Then sample must be paired. I have already told you, if you have one group, so you are doing a pre-testing on that group, and the same group will act as a post-test. So therefore, I become my own pair. That is the meaning of the paired. That means you cannot have three groups. Once I say paired, paired means you only can have two groups. You cannot have three groups. So it is only applicable when you have two independent groups. Okay? And once I say they must be dependent, means the same. When I become my own pair, then I depend on myself. That is the meaning of this. Then here independent samples can, that means you cannot have in the pre I am there, in the post someone else is there. You cannot do that. So that is the meaning of the fifth one. So that means let us see how do I proceed. Let us have one title. And I told you yesterday that if you have pre-test, post-test, single group design, in that you can use it. Okay? So therefore, if you want, you can have the something like title might be a study of weight of a study of weight of, let's say, 26 years males, 26-year people belonging to Ajmer. If this is my title, I may have an objective like this. Or if you like, you can write a title like this also. A study of effect of physical exercises on weight of 26-year people belonging to Ajmer. So I may have an objective like this to compare mean, rank, scores of weight of people before and after physical exercise. So you have to take one group and then you have to take their weight and then ask them to do the physical exercise for a particular period of time, let's say maybe 1 month. So after 1 month, you have to take the weight of the same people again. So that means in the assumption, I should also mention that the data must be on ordinal scale. If the data are on interval scale or ratio scale, but do not satisfy the assumptions of parametric test, sign test can be used. And now let us go ahead. If this is my title and this is my objective, then what can be my hypothesis? Navita, I will tell you. So here hypothesis is that there is no significant difference in mean rank score of weight of people before and after the physical exercise. Say here, I told you the Wilcoxon sign rank test. And in this one, if suppose your paired samples t-test, you know there is a statistical technique called paired samples t-test. If that particular statistical technique cannot be used, then it is up to you whether you want to use Wilcoxon signed rank test or you can use the sign test. Number two, in the Wilcoxon signed rank test, your sample size should be at least 16. But in the sign test, your sample size may be less than 16, it does not matter. So therefore, these are some of the differences. Otherwise, your Wilcoxon signed rank test or your sign test, I will take the data and I will analyze with the help of both the statistical technique, and you will find results are same. So therefore, it is your choice, whatever you want to do that you can do. So let me now take the data and analyze it. So let us go ahead with let us have another 5, and now you can say that here I will be having pre-weight and I will be having the post-weight. So you have pre-weight and you have post-weight. You have one group, the same group you are assessing with the help of whatever is the tool for the weight, and then they are doing some exercise, and then you are again testing. So we go to the data. So here you can have your pre-weight, suppose 50, 45, 48, 49, 41, 42, 52, 50, 48, 47, 45.5, 49.5, 50.5, 46.5, because weight can be in fraction also, it doesn't matter. Suppose we have this much, and suppose the post weights are, suppose it is 48, it is 44, it is suppose 48, it is suppose 47, it is suppose 40, it is suppose say 40, it is suppose 48, suppose 49, suppose 47, suppose 43, suppose 44, suppose 46, suppose 48, and suppose 46. Because some of the people weight may not change after having done the physical exercise for 1 month. It is possible. So let us go ahead and we go to the non-parametric, and here is a 2 related samples. So you have pre and you have post. Now your Wilcoxon is already there. So I want sign test. So let us have the sign test. Now this is non-parametric, and this is the negative difference, and this is the positive difference. And this is your statistics, post weight minus pre-weight. It is significant. That means when he said negative difference, that means the weight of the people have decreased after the physical exercise. That's the meaning of the negative weight, negative difference. Because pre is more and post is less. So pre minus post will be, it has to be post minus pre, it will be negative. So that is why it says negative difference. And negative difference means that due to physical exercise, the weight of the people have decreased, and it is decreased significantly. Let us have another data. I have the data for 18 people, because then you can use Wilcoxon also, and I will do, and let us see what will be the answer. Suppose I have 19. And now here is say 47, say 45, say 47, say 48, say 44. Now I can use Wilcoxon also, and I can use the sign also. Let us see. We go to non-parametric, we go to k-related, and now I have the pre. I have the pre and I have the post. And I do Wilcoxon also. So let us see what is the difference in the results. Now, this is sign. And this is your Wilcoxon sign rank. And now here you say your Z value is significant at 0.01 level. And it means the negative ranks are more. That means now, due to physical exercise, the weight of the people has reduced significantly. This is what Wilcoxon sign rank test, sign test. Now let us say what is the answer of the sign test. Now sign test also says that negative difference is 16 and positive is 0. That means, and it is significant. That means the weight of the people has decreased significantly. So it is the same data you are analyzing with the help of Wilcoxon or sign rank. It does not matter, the answer will be the same. As I told you that if you have the data and you analyze with the help of a t-test, when you have two independent groups, and the same data, if you analyze with the help of ANOVA, one-way ANOVA, you will find the value of the T and the F will give you the same result. And the relationship between T and F is the square root of F is equal to T. So when you have two independent groups, then it is up to you whether you want to analyze the data with the help of t-test or one-way ANOVA. Similarly, here also it is up to you. If you want to use Wilcoxon, you can use. If you want to use sign, you can use. Absolutely no problem. Answer will remain same, except you have to see. If you want to use Wilcoxon, you should have 16 observations. Sign, you can have any number of observations, 8, 9, 5, any observation. Of course, it cannot be 1. So that is what exactly is the one. So now do you want that I should only interpret the sign, or I should interpret both Wilcoxon also? Because Wilcoxon I have already interpreted yesterday, so I don't think that you know that. Sunita, I hope you have understood now. All right. So I will only explain the sign test. So let us see the sign. You can note down the values for the negative difference and positive difference. So you want to write positive first, you can write. You want to write negative, you can write. So here it is n is 16 and no, it is 0 and it is 16. And your sign test is, it is significant. It is significant at 0.01 level. Now, another thing you can see here is that in case of Wilcoxon signed rank, we are writing the word mean ranks. And here, let's say, what have I written? Now here will be the two compare mean rank. So that means we are not able to compare the mean ranks here. We only like to compare the change in the weight, to compare not mean rank, to compare number of changes, to compare number of changes in weight of people before and after the physical exercise. And then here we should write that there is no significant difference in number of changes. There is no significant difference in number of changes in weight of people before and after the. So here, this is your objective. So now you can see another difference between Wilcoxon and sign. And now here we say it is 4.16.0. Here we say testing wise, comparison of number of changes in weight of people. And then I say the 16th objective was to compare the number of changes in weight of people before and after. the data were analyzed with the help of sign test, and the results are given in table 4.60. 4.60. So here I say change, and then here I say the number n, and then here I say the remark. So here change is positive, another is negative. In the positive it is 0, and negative it is 6. And remark is that p value is 0.01. So here direction wise number of changes in weight of people due to physical exercise. So here you can see from table 4.16, it can be seen that the difference in number of changes is significant at 0.01 level. So it indicates that the number of positive changes, that it indicates that there is a significant difference in number of positive and negative, that there is a significant difference in number of positive and negative changes in weight of people. Thus, the null hypothesis that there is a significant difference in there is a significant difference in number of changes in significant difference in number of changes in weight of people in reject. It can be now further number of changes in negative weight of people is age 16 is 16, which is significantly higher than the positive change which is 0. So it may be said that after the physical exercise, the weight of people has significantly decreased. So therefore, this becomes, we are finding, or if you want to say that the physical exercise was found to be effective, it may also be said that physical exercises were found to be effective in reducing the weight. So this is what, if you like, you may say the last one to be your finding. Perfectly all right, nothing wrong in that. Is it all right? Do you want me to take another example where the change is not significant? Do you want me to take another exercise, or is it clear? Sunita, I don't understand your answer. You say, sir, what does it mean? Shalini is very clear when she writes. Okay. So therefore, if it is all right, then perfectly correct, then I can close it here, and then you can do the more reading from any book that you come across where the sign test is given. And then tomorrow I will be taking up McNamara test. So if you can read beforehand something from some book about the McNamara test, then you will be able to understand. Sunita, you use sign test when you are not able to give the rank. You are not giving the ranks. And you only try to find out in how many number of the cases the change is positive and how many number of the cases the change is negative. And whether the change in the number of the cases positive and negative is significant or not. So let me take one more example. Yes, here null hypothesis is rejected. I hope it has, haven't I read? I have written that the null hypothesis that there is a significant, that there is no, oh, I'm sorry, there is no significant difference in number of changes in the weight of the people is rejected. So null hypothesis is rejected because there is a change and there is a significant change. Let me just take one example, another example, and try to see whether the number of the cases in the positive and negative, they are the same or not. Let me just have one more example, and for your understanding purpose, and let's say, suppose I'm taking let's say I'm taking again pre-weight, and I'm taking, or why pre-weight? I say pre-achievement in any subject, and then post-achievement in the same subject. So let us have I have the data out of 30. And let's say here is 15, 18, 20, 21, 23, 22, 24, 26, 8, 19, 18, 20. Suppose I have, say post is, suppose this is 16, suppose this is 15, suppose this is 21, suppose this is 19, suppose this is 20, suppose this is 24, suppose this is 24, suppose this is 28, suppose this is 20, suppose this is 18, and suppose this is 19. So somewhere it is positive, somewhere it is negative. Let us see, and what do you get it? And we Forget about the Wilcoxon because the number is not 16, it is 11. And let us see what is the value. Now you can see the post-achievement minus pre-achievement. Now, how many are negative? 4 are negative. How many are positive? 5 are positive. And there are ties in 2 cases. And the value is not significant. So yes, it can happen that whatever the intervention that you are giving, due to that intervention, it is possible in some of the cases, the scores may increase. In some of the cases, because of the confusion, the scores may decrease. And if it is so, then your value is not significant. So here you will say that your null hypothesis is rejected or not rejected. What will you say? What will you say? So here null hypothesis is not rejected. So that means the changes due to the treatment, there are equal number of the changes, positive as well as negative. Some have improved and some have not improved. So therefore, it can happen that your value may not be significant or your value may be significant. In case of Wilcoxon, although the finding will be the same, okay, if you want, I can just change the values little bit and let's say some more values. Suppose I have the 17 values. Now let us analyze it with the help of both. So these are the same. I can have this is pre and this is post, and let me have Wilcoxon also. And let us see whether the result will be the same or it will be different. So here you can see, this is your Wilcoxon. And in Wilcoxon, your Z value is not significant because the error is 72%. So that means the mean rank of the positive and negative do not differ significantly. That means due to the intervention, some of the people improved and some of maybe equal number of the people improved and approximately equal number of the people did not improve. That is why there is no significant difference. Let us see the sign test. Now in the sign test, also just see negative are 7 and positive are 7. And they are not different. So that means due to the intervention, equal number of the people improved and equal number of the people did not improve. Or equal number of the people have improved and the equal number of the people, their achievement has decreased. So you can see that in Wilcoxon, when you are comparing the mean rank, and in sign, you are not comparing the mean rank, you are comparing the number of the people in which the change has occurred, positive change or negative change. Answer is the same. Is it clear or it is not clear? Yes, please. Is it clear or not? So therefore, now you can decide when you have the data and you decide whether you want to use Wilcoxon or you want to use the sign. And whatever you do, only the number of the cases in Wilcoxon, it must be minimum 16, maximum there is no limit. In sign test, there is no limit whether minimum can be 10, can be 5, can be 8. It can be any, it can be 20, it can be 100, nothing to worry about that. Result will remain the same. Is it clear now? So therefore, now I am closing it here. And I think the room where I'm sitting right now, tomorrow also I will sit here only so that there is no wastage of the time. And I'm sorry for the today's, but it's not within my limit. It is beyond my limit. The hotel people helped me to open another room where they said signal will be very nice, and here it is very good signal. So thank you very much. See you tomorrow and try.
Thank you, sir. Many thanks to you, sir.
Okay, bye-bye.
Bye, sir. Good night.